For this next example problem, and this is example 9-2, let me just do that, example 9-12. I copied over my picture that I had in the previous example problem, and mainly so that way we can kind of see the direction we're going. This is the 30,000 bird's eye view. I call it the 30,000 foot bird's eye view. It's just because you're seeing it from above, and this is, you know, the direction you're taking. Of course, let's see, 30,000 feet. Yeah, that's about right. All right. I'm wondering, is that like in space or something? I don't know. Anyway, how many moles of phosphoric acid can be formed from 3,550 grams of diphosphorus pentoxide? So, diphosphorus pentoxide. That would be the P2O5. All right, and then I need the balanced equation, of course. P2O5 plus 3 moles of H2O will give me 2 moles of H3PO4. All right, so I'm just going to kind of give you an idea of where we're going. We're going to start here. We start off with the mass of diphosphorus pentoxide. We're going to need the molar mass to convert 2 moles of diphosphorus pentoxide. Then we're going to use stoichiometry to get from here to here. And then we're going to stop. And the reason why we're stopping there is because they asked for how many moles of this stuff we need. So they didn't ask for how many grams of it or how many atoms it could be created. They just asked for how many moles. So that's where we're going to stop. If they asked for grams, then we would travel down that leg and all that kind of stuff. All right, so for our problem, let's see, we need the molar mass of P2O5. P2O5, let me just write that down, P2O5. I'm sure that you've gotten really good at getting the molar mass, and so that is 141.9 grams per mole. 141.9 grams for every 1 mole of P2O5. All right, so I'm going to start off with 3,550 grams of P2O5. And you know what I'm going to do is I'm going to color code this so that we know the steps that I'm taking. So for the blue step, and that is going from mass to moles, what I need to do is I'm going to make it so that I have grams on the bottom. So I have 141.9 grams is associated with 1 moles. I'm going to put that 141.9 grams on the bottom. I'm going to put that 1 mole of P2O5 on the top. Now normally I don't write, I just put 1 mole and I don't put the P2O5, but I'm going to do that now just because I have to be very careful with, you know, what I'm dealing with here. This grams cancels out with the grams, and that's my favorite thing to do. So now I'm on the bridge. I'm at the beginning of the bridge, and I need to cross that bridge using stoichiometry. So now we're doing the red step. So I want to associate this 1 mole of that stuff to that 2 moles of that stuff. Well, that's pretty easy. There's 1 mole of P2O5 for every 2 moles of H3PO4. That's stoichiometry, and I got those numbers straight out of the balanced equation. That's how easy that is. It really isn't that hard. It didn't require anything. It's just 2 numbers. There we go. So my favorite part, canceling this out, that moles cancels out with that moles, and I'm left with moles of H3PO4, which is actually what I wanted as my answer. So when I multiply everything out here, I end up getting 3,550 divided by 141.9 multiplied by 2, and I end up getting 50.0 moles of H3PO4. Because my units in the end is moles of H3PO4, which is what I wanted in the end. So that is my answer.